This is Professor Belton. This is Trigonometry, Chapter 2, Section F, the frame method. This is Part 1 of 3. Part 1 is going to do the sine frame and the cosine frame. The frame method is an alternative shortcut method to graphing the sine, cosine, and other trig functions. It's on the premise that all of the functions essentially look the same. They're just modified with the period, amplitude, and their starting point. So every sine essentially looks like this, where the high points are equally spaced from the midpoints and the endpoints. And it uses the formulas we've previously learned in the previous section. So first, the starting point is the phase shift formula, which gives you your x equals. The endpoint is the period plus the starting point, which makes sense. It gives you how long it is plus where you started. And then halfway between that is the midpoint of the sine function, and then the d value, or the vertical shift, plus the amplitude, and the vertical shift minus the amplitude, which is the absolute value of a, will give you the top and the bottom of the function, and then halfway between that is the midpoint, or the new axes. Okay? And they're all premised on the fact that sine can be written with a, b, c, or d, which may or may not be there. A and b are 1 by default, and c and d are 0 by default if they're not specified. And the same is true for cosine. The only difference of being is the default points are different as far as their locations, because cosine essentially always looks like this, always differing. Okay? And you can get the initial points of sine and cosine by, again, looking at your unit circle, because the unit circle starts at 1, 0, cosine, sine, whereas the cosine starts at 1 at the top, whereas the sine had started at 0. And it goes all the way around, of course, so we have 0, 1, so we're back down to the axes for 0 for cosine, and then negative 1, 0, we bottom out, and then 0, negative 1, so we're back to 0, and finally back to 1 again, so on and so forth. But they're not going to be 1s necessarily anymore, because we're shifting, or nor zeros. Okay, let's do some examples. So first, remember, the reason why we can add them up and divide by 2 is the midpoint formula. Of course, we're not doing a and b, we're doing the different endpoints. Okay, so prior to the graph, we're going to do the frame. So let's fill out the function completely. So if we add a 0 onto the end, it'll give us our d value. So a is 5/2, b is 2, c is pi over 2, and d is 0. However, this is incorrect, because remember the original formula is y equals a times sine of b, x minus c plus d. This is a minus c. So therefore, since this is a plus, it had to have been minus a negative to get that pi over 2. So this has to be a negative pi over 2. Okay, so first off, this is a sine function. So therefore, the points arrangements have to be like this. And what's going to change is the values of where they're located. So first off, let's get where it starts. Okay. So the phase shift, that's going to be x equals c over b. So in this case, my c is pi over 2, and the b is 2. Okay, but this is negative, so we'll multiply it by 1/2 over 1/2. So that'll give me a negative pi over 4, which is our starting point. So that's negative pi over 4. So this is going to go some distance. We need to get the endpoint now. So we need to figure out how far this is going to go, which of course is the period. So the period formula is 2 pi over b, but b in this case is our 2. So we get pi for the period. Okay. Alright, so this goes some distance from here to here, which is going to be a distance of pi. But we didn't start at 0, we started at negative pi over 4. So it's from negative pi over 4, we have to go pi over. So that's negative pi over 4 plus pi. Okay? So if you turn that into fourths, that's negative pi over 4 plus 4 pi over 4, if you make common denominators. So in fact, that's 3 pi over 4. Okay, so we'll delete this a little bit here. So this is 3 pi over 4. So I guess the total distance of pi now. Okay, let's delete all this extra work over here. You can refer back to the formulas on the formula page to reference these. So now the remaining points are halfway in between. So halfway between negative pi over 4 and 3 pi over 4, which are the endpoints, gives us our midpoint here. So we'll add those up. So negative pi over 4 plus 3 pi over 4, halfway between there, is going to give us 2 pi over 4 over 2. So multiply by 1/2 and 1/2. Cancel, 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 cancel. Leaves me with a pi over 4 is halfway in between. Okay, so again, just add them up, divide by 2, get halfway in between. Alright, let's do the next one. Okay, so next one we can probably figure out between negative pi over 4 and pi over 4. That's 0, because you add them up, you get nothing. Divide by 2, you still get nothing. Alright, next one, pi over 4 and 3 pi over 4. If we add up pi over 4 and 3 pi over 4, and go halfway between those, we'll get 4 pi over 4 divided by 2. So multiply by 1/2 over 1/2. Cancels. That leaves us with a 2 there. So that leaves us with a pi over 2. Let's make that a little bit clearer here. Okay. Alright, so now we have our x-axes. Now we can make our y-axes. Our y-axes is going to come from the amplitude and the d value. Okay, so let's erase our work over here. Okay, so our amplitude is the a value, so that's 5 over 2. So this is d plus the amplitude, and this is d minus the amplitude, or the a value. So if we do that, we get our 0 plus the 5 over 2, and the 0 minus 5 over 2. So that gives us 5/2 for the top, and negative 5/2 for the bottom. If you add those up and divide by 2, of course, you'll get 0 because they cancel each other out. So there's our frame. So this goes on forever, though. So it's going to go from negative infinity to the left and positive infinity to the right. And it's parentheses because they keep going forever. You can't get to the end. Okay. However, the domain and range up and down, the range up and down, it is maxed out and minned out at negative 5/2 and positive 5/2. Okay, so using this, now we can make our proper graph. So the question is, how do you number it? Well, when you number your graph, look at the fractions, and the largest denominator is what you use. So the largest denominator in this case is 4 on the x-axis and 2 on the y-axis. So that is, in fact, how we will number the graph when we graph it. Okay, so if it's 4 on the x-axis, that's going to be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. And finally 8/4 is 2 pi. And go in the negative direction. Negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, and negative 7/4. And negative 8/4, of course, negative 2 pi. Okay, so according to our frame, we started at 0, negative pi over 4, and then we went up to 0 was 5/2. And then pi over 4 was the other 0. And then pi over 2 was the negative 5 halves. And then finally, 3 pi over 4 was the final 0. So check your frame up above. So the frame up above, you'll notice, is not to scale, but the graph is to scale. So the frames will always be the same size, different numbers, but the graphs will be different numbers, but different scales, so they'll actually fit properly. All right, pause the video, try the next 2 student problems. Okay, the next graph is a cosine graph, but the key here is this one's negative, so therefore it's going to be an upside down cosine. So we'll draw our cosine, but this cosine is in fact upside down. Because every positive value becomes negative, every negative value becomes positive, and 0 still stays at 0. Okay, so we'll fill in our, we'll rewrite this function here. So this is negative 2 times cosine of 3x minus 0 plus 1. So we have all the values in there. So a is negative 2, b is 3, c is 0, and d is 1. Okay, so let's get our initial value. So we need our phase shift. So the phase shift is x equals c over b. C in this case is 0, and b is 3, so we have no phase shift. So in fact, this graph actually starts at 0. Okay, now we need our period. The period is 2 pi over b. So 2 pi over 3. So this will in fact end at 2 pi over 3 this time, because the entire distance is in fact 2 pi over 3. So form 0 would be 2 pi over 3. So this one's a little bit easier this time. Okay, so let's delete that. So now we have to do a little math to figure out the ones halfway in between now. So if they add them up, so 0 plus 2 pi over 3 divided by 2. So that's 2 pi over 3 divided by 2. Times it by 1/2 over 1/2. Cancels. Cancels. So halfway in between is pi over 3. Okay, so halfway between these now, pi over 3 plus 2 pi over 3 gives me over 2. Halfway between is 3 pi over 3 over 2. So that'll cancel. So times 1/2 over 1/2, that'll cancel. So that gives me a pi over 2, halfway between there. And then lastly, we have pi over 3 plus 0 divided by 2, gives us the last x-axis point in between. So that's pi over 3 over 2, times it by 1/2 over 1/2. Cancels. That gives us a pi over 6. That concludes our x-axis. Now we'll do our y-axis. Okay, so for our y-axis, we need our amplitude. Our amplitude here is in fact 2, because it's the absolute value of the a value, can only be positive. Our period was 2 pi over 3. Okay, that's a bad 2. Let's fix that. Okay. Alright, so we want to figure out the min and max values. So that's d plus my amplitude and d minus my amplitude. Well, d in this case is 1. The amplitude is going to be 2 when d to the absolute value, and d minus 2. So that'll give us a 3 for the top and the negative 1 for the bottom. So if we add those up, 3 plus negative 1 and divided by 2, we'll in fact get a 1 for our other value. Okay, so now we can figure out our domain and range. So it goes forever left and forever right, because you can keep going forever with sine and cosine as far as the angle goes. However, the min and max range is going to be -1 to 3, but you can be those values, so we need to put brackets, whereas you can't get anywhere to the left and right. You can't get to the end, so it has to be parentheses. Okay, let's use this and make our graph. So again, look at the fractions, and the largest denominator is the denominator we must use. So here we have 6, 3, and 2 for the denominators. You must use 6, which is the largest denominator. And on the y-axis, you have whole numbers, so you can use these whole numbers there. Okay, so we're going by 6 this time. That is the largest denominator. Okay, so the y-axis is done. That's whole numbers. So we go by 6th here. So we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6 is 2 pi. Okay, so we started at 0 at the -1 value, and we ended at 2 pi over 3 as the other 0 value. If it helps you, put in a dotted line for the new axes, because essentially these dotted lines aren't here, but it can help you in the graphing part. So we went up to 3, and we bottomed out at -1. Okay, so those aren't really there, but it helps as a good visual. So at pi over 6, we were at 0, or the new -1. And then the pi over 3, we're at the -3, or +3. And then the pi over 2, we're at the new 0, which is a 1. So that gives us our initial cycle of cosine upside down. Okay, next student problem. Okay, so the next one is another sine, so we'll rewrite the sine function. So this is 4 times sine of pi x minus 0 minus 2. So in fact here we have a is 4, b is pi, c is 0, and d is -2. Alright, so this is a positive sine, so we can, it's a standard sine graph. So now we just need to get our axes numbers. So we'll start with a phase shift. So phase shift, that's going to be c over b as our x value, but our c is 0. It doesn't really matter what the b is in this case because it's going to be 0. So we don't phase shift, we just start our graph at 0. So we figured our period now. So period, excuse me, 2 pi over b, or 2 pi over pi leaves us with a 2. So that means this distance from 0 to 2 later ends at 2. Okay, so that's not going to be in terms of radians pi's anymore. It's just a whole number of radians. Alright, so halfway between 0 and 2 is 1. Halfway between 0 and 1 is a half. And halfway between 1 and 2 is 3 halves. That's a little bit easier this time. Okay, so we'll do our min-max. So that's d plus my amplitude, and d minus my amplitude, where d is -2. Oops, that's a minus. There we go. So in fact this time we get a 2 to -6. Okay, so if we add those up, 2 plus -6 divided by 2, that gives me a -2. So there is our new graph. So our amplitude was 4, because that was our original a value, which has to be positive. It goes forever for the left, never to the right. It goes on forever. However, this one maxes out at 2 and bottoms out at -6. And those are values you can reach, so use the brackets. Okay, so in this case, the only thing that's different is that we have all nice rational values, no terms of pi whatsoever. Still radians, but that's fine. Okay, and again, the biggest fraction denominator here is 1/2. So down here, the denominator will be 1/2. Okay, so we have 1/2, 2 halves, 3 halves, 4 halves, 5 halves, and 6 halves. -1/2, -2 halves, -3 halves, 4 halves, and 5 halves. Okay, so this one goes between -2 is our center, is our new center. Our top is 2, and the bottom, of course, is -6. Okay, again, those dotted lines aren't there, but they're a nice reference as far as to where to put the points. So at 0 we started at the -2, and at 1/2 we were at 2. At 1 we're at the new bottom out, which is -2, and 3 halves we're at the -6, and at 2 we're at -2. Okay, so there is our initial cycle of sine. Okay, that's the end of part 1.